designed for general and combat missions. They represent a great deal of money and are key weapons in the defense of the United States. As a pilot, your first experience with jets will probably be in the T-33 trainer. But the skill you acquire in flying these trainers will be vital in terms of your future. One of the most important techniques you must learn during your training is that technique of landing the airplane. If there were no weather or other air traffic at a given field, getting down from your cruising altitude onto the runway would be no particular problem. All you'd have to know is how to fly the airplane. But when weather closes in, you have the added problem of finding the runway. However, there are various navigational and approach aids to help the pilot solve this problem. If there were no other airplanes in the vicinity of the control zone under IFR conditions, the only problem would be to land in the quickest and most economical way. The overcast would not create any great problem. The purpose of this film is to illustrate penetration and approach procedures in such a way that you can see and remember the principles that will be important when conditions are such that you can't see anything. If you learn these lessons, it'll be almost as if you can see the airfield, obstacles, and other traffic. For these reasons, definite approach procedures have been established, which must be followed. When a pilot requests clearance for an instrument approach, he must follow a prescribed flight path from his cruising altitude until he is safely on the runway. You may approach the airfield from any direction and come in on any one of the range legs. The tower will then direct you to use one of the legs for your approach, or, as we shall see, may direct you to make your approach in an open quadrant. For your protection, these approach procedures have been standardized as much as possible, so that once you've learned them, you can go to any field that has these facilities in just about any weather, traffic or no traffic, request an instrument approach, and know you're going in. Naturally, there are differences from one field to another, depending upon terrain, normal traffic flow, and the available radio facilities. You'll find how these approaches vary in your Jet Pilot's Handbook. For IFR letdown, this is your Bible. One of these should be with you in the aircraft at all times. An instrument approach has two main parts. One, penetration, which brings you from your cruising altitude down through the murk to a fix. And two, low approach, which brings you into position to get onto the runway. First, we'll consider the penetration portion of your approach. If traffic conditions at the moment require any changes from the published procedure, the approach controller will tell you so when you first report into him. There are three distinct parts or phases to every penetration. The initial penetration altitude, at which you start your penetration over the fix, the penetration turn, and the initial approach altitude. Regardless of your cruising altitude, you should make good your initial penetration altitude at the point where you pass over the fix before starting your penetration. This is nearly always 20,000 feet. As a general rule, you plan to lose 1/2 of your penetration altitude before you make your penetration turn. But this is one of the details that varies from station to station. The published chart will tell you which way to make that turn, left or right, as well as your exact headings and altitudes in all parts of the turn. You are now coming down to your initial approach altitude, which you will maintain until you again pass over the fix. When you arrive at this point, you have completed your penetration. Let's just go back over this part of the procedure again and pick up some of the fine points. On a typical cross-country, your cruising altitude will almost always be somewhat higher than your initial penetration altitude. Obviously, this means that you want to report to approach control as soon as possible, so that he can give you letdown instructions and an expected approach time. For various reasons, you naturally try to plan your flight so that you arrive over the station exactly at your initial penetration altitude, 20,000 feet. An altitude higher or lower than 20,000 feet can complicate your penetration. If you're higher than 20,000 feet, you'll have to travel much farther from your radio fix in order to get to your initial approach altitude, which not only wastes valuable time and fuel, but also brings you out over unfamiliar terrain. If you arrive at the fix below the initial penetration altitude, it may become necessary to hold or to go to your alternate. Because of the low altitude, fuel consumption is higher, and it may not be possible to hold or to reach your alternate. And finally, starting too low will bring you to your initial approach altitude too close to the station for proper clearance from any traffic over the station. Your penetration should enable you to arrive at the initial approach altitude inbound a minimum of 10 miles from the station. So begin your penetration at the published altitude, never lower. Now let's start the penetration. Generally speaking, we can classify all penetrations under two main headings. Range penetrations, which utilize oral signals throughout, and ADF penetration, which make use of the automatic features of the radio compass. Your actual penetration will often combine these two methods. Let's take a range penetration first in an example where there's no traffic on the penetration leg. You reported to approach control about 10 minutes ago and are instructed to start your penetration at 20,000. You're coming in on the published penetration heading, orally following the beam. You hit the cone of silence, there's your fix. You're at 20,000 and want to get to the published initial approach altitude of 2,500 feet, which means that you want to be halfway down when you start your penetration turn. So when your altimeter indicates 11,250 feet, start your penetration turn. Left 45 degrees as per instruction. Then right until you're headed inbound on the penetration leg. If you've made your turn and descent properly, you hit the initial approach altitude of 2,500 feet when you're at least 10 miles from the fix. Hold this as you continue inbound until you reach the cone again. This completes your range penetration, and low approach begins. But first, let's go back to some other types of penetration. Here's an ADF penetration. This time, there's traffic on all legs and a stack 4 high over the station. The approach controller will probably give you priority over conventional aircraft, but first he has to clear the initial approach altitude. Then he clears you to start your penetration. With all that traffic below you, the approach controller will instruct you to make your penetration in an open quadrant away from the stack. Turn back inbound only when you've lost half of your penetration altitude, and return to the range station at 2,500 feet. By maintaining this initial approach altitude, you will be clear of your friends up there in the stack. Again, you are over the fix, ready to begin your final approach. Here's another situation, again requiring ADF for the actual penetration, though you'll use oral signals both before and after it. This station, very obligingly, has a low-frequency homer 10 miles out on the final approach leg of the station. There's a stack over the station, but none over the homer. In that case, you'll be directed to start your penetration into the open quadrant, making good a specified track. You'll make your turn after losing half of your penetration altitude, no lower, in order to assure proper terrain clearance. Then you fly the radio compass needle to head back toward the homer at your initial approach altitude of 2,500 feet. As you hit the homer, you turn to your final approach heading, and that's all there is to it. From this point, you are ready to start your low approach. That little homer has saved you an extra 25-mile ride plus one procedure turn. Notice that in this case, your penetration began as usual over the range station, but ended over the homer at 2,500 feet. In this case, you have traffic between the homer and the range station, and the terrain makes it unsafe to use an open quadrant. Here is another type of penetration. Fly over the homer to start your penetration, holding your same heading, and cross the homer outbound, which tells you definitely that you're more than 10 miles out. Again, you make your letdown to initial approach altitude on ADF, making a penetration turn that will bring you back toward the homer. cross it at 2,500 feet for final distance fix, and you're inbound to the runway, ready to begin your low approach on the final approach leg of the range. Notice in this case that although you have made your first radio fix as usual over the cone, your actual penetration began over the homer and ended over the homer. There is still another type of penetration. In this one, use the oral signal until the penetration turn is interrupted. Then switch to your ADF to return to the homer. In this situation, you have a homer 10 miles out, and no other traffic holding either at the homer or on the penetration leg. You come into the cone on your oral range, and have been advised to start your penetration at station. You start your penetration, still on oral signals, letting down to half your penetration altitude. Making your penetration turn, still on oral. Then as you complete it, tune in your homer frequency and switch to ADF. You arrive over the homer on your initial approach altitude, ready for low approach. Your penetration in this case began over the cone and ended at the homer. And once again, the homer has saved you 40 or 50 gallons of Uncle Sam's very best kerosene. One thing all your penetrations must have in common: you never descend below your initial approach altitude during any part of the penetration proper. This guarantees that you have adequate clearance above any and all terrain features and other obstacles until you are safely inbound over a definite fix. Of course, the pilot's dream is to have a GCI setup at his destination. This unit can pinpoint you in space, anywhere within 75 nautical miles of the station. It'll bring you in with minimum turns, save you time and fuel, and put you in a position to make a straight-in or a GCA approach. It allows penetrations to be made much closer together. Knowing your penetration procedures well is half the battle, but the other half is pilot technique. Making IFR penetrations means 100% precision. No almost and no maybe. As always, in flying these sensitive airplanes, a great deal of this technique will be left up to what we hopefully call the pilot's judgment. And that judgment must be exercised within well-defined procedures. Let's take airspeed as an example. Airspeed is so closely tied in with configuration that it would be impossible to standardize one or two penetration airspeeds that would suit all airplanes. Taking the T-33, we have been able to arrive at two penetration airspeeds, which have proven their value in almost every type of situation. We call them the low-speed penetration and the high-speed penetration. With slight modifications, you will find them useful guides to safe and efficient letdowns in just about any jet airplane you may fly. The low speed is the one you will use most, since it applies in practically all weather, except in violent turbulence. And here's the procedure for a low airspeed letdown in the T-33. 1, reduce power to 65%. 2, lower your dive flap. When your airspeed has fallen to 196 knots, lower the landing gear. And when your airspeed reaches 175 knots, lower your wing flaps. Lower the nose of your airplane until the horizon bar is lined up approximately with the 60-degree mark on the banking index. When the airspeed drops to 150 knots, the airspeed indicator becomes the primary pitch instrument, and the vertical speed indicator becomes the supporting instrument. 1,000 feet above your initial approach altitude, you pull up the garbage, start your roundout using the attitude indicator to level off at the initial approach altitude. When your penetration is going to be made through possible icing conditions, you naturally make it at a high rate of descent. In that case, you only use your dive flap. Throughout the penetration, the heading indicator will be primary for bank during the straight parts of the maneuver, and your turn needle during turns. All turns will be at a double needle deflection unless the angle of bank required to execute it would be greater than 30 degrees, in which case you will use a single needle deflection. In leveling off from the high-speed descent, the amount of lead will always depend upon the pilot's own judgment and technique. But once again, you'll probably find that 1,000 feet of lead is about right to give you a safe level off. As soon as you've leveled off at your initial approach altitude, you reset the throttle to hold your desired approach airspeed, 175 knots. When you pass over the fix again to complete your penetration, you're ready for the low approach. Procedures for low approach on instruments are exactly the same for jets as any other airplane. There are 5 methods of making low approaches. Range, ADS, VOR, ILS, and GCA. The local approach controller will clear you in one of these methods, depending on the weather, the traffic he has, and of course, on which facilities are available there. ILS or GCA will be used if they're available, since both these facilities, being specifically designed to aid low approaches under IFR, give glide path information. That is, they fix your position in elevation as well as your track in azimuth. As you go from the penetration phase to the low approach phase, the need for precision flying technique becomes greater. Let's put it this way. The penetration is just a method of getting you down to the initial approach altitude. The low approach is the actual getting in. The low approach is, in short, the payoff. Normally, the low approach can be considered to have 4 parts or phases. 1, the descent from initial approach altitude to procedure turn altitude. 2, the procedure turn. 3, descent from procedure turn altitude to final approach altitude. And 4, final letdown. Your procedure for the low approach will depend upon the ceiling as well as on the layout of the field. Depending on these factors, you'll use different flying speeds to bring you up to the point where you can land on the runway. In any case, as you pass through the cones, lower the dive flaps and start a descent, maintaining an airspeed of 175 knots. The idea is to get down to your procedure turn altitude in no more than 1.5 minutes. After making your procedure turn, you're in position to head for the runway. The airspeed you maintain during the low approach will be determined primarily by your configuration, and that in turn will be determined by the ceiling. When the ceiling is 1,000 feet or more over the field, you'll plan to make a normal landing. That means use your dive flaps to descend at downwind airspeed of 175 knots until you reach VFR conditions. When the ceiling is 500 to 1,000 feet, as you complete your procedure turn, drop your gear and descend at a rate of 500 feet per minute until you reach the final approach altitude at a base leg airspeed of 140 knots. Hold this until over the station. Then make a 500 foot per minute descent, maintaining the base leg airspeed until you have the field in sight and a normal landing can be accomplished. In case you have an emergency and must make an approach when the ceilings are below minimum, 500 feet, upon completion of the procedure turn, the configuration is set as for GCA final. Start a descent of 500 feet per minute until the final approach altitude and final approach airspeed is reached. Maintain this until over the station. Then start a descent at 500 feet per minute until you reach your minimum, or time from station to field is up. At this point, you should be able to land. If not, a missed approach procedure is followed. If the time from the station to the field is less than 2 minutes, the preceding procedures will be followed. If the time from station to field is more than 2 minutes, you may not desire to set up your configuration until over the station at final approach altitude. In general, the low approach pattern illustrated will apply whether you're flying on oral signals or on instruments which bring you to the runway. The instrument approach procedures illustrated in this film show principles only, not actual conditions. Actual altitudes and flying conditions will vary. But throughout your penetration and approach, you'll assure proper clearance by adhering to the published altitudes or instructions for each landing. Remembering and